In this video, I'm going to talk about how the law of conservation of momentum can be used to analyze an elastic collision. So an elastic collision, if you recall, is one where the two objects bounce off one another. Um, so I'm going to have two cars here, and I'll call them mass 1 and mass 2. They're going to have a mass 1. It's going to be 2 kilograms. Mass 2 is going to be 1 kilogram. And I'm going to say that the initial velocity of car 1, v1i for initial, is 5 meters per second. So it's traveling like this, 5 meters per second to the right. And then the initial velocity of the other car, v2 initial, is going to be 2 meters per second. So they're both traveling in the same direction, although car 1 is going faster, so there's going to be a collision. There's going to be a collision at some point in time. I'll say the collision occurs here. And then after the collision, I want to determine the velocities of the two cars. And what I'm going to say is that this one slows down, v1 final, slows down, and it slows down to a velocity of 2 meters per second. And I want to find out what this car's velocity is, v2 final is, after the collision. That's the goal. So I want to find v2 final, the velocity of car 2 after the collision. So the law of conservation of momentum, the model, is a 5-step process. So first step, we define a positive direction. So on the diagram, I define a positive direction here. That's important because velocities are vectors, and so things may go in reverse and be negative velocities, so it's very important to define the positive direction. The second step is we make a statement of the conservation of momentum. In other words, we make the statement, but more importantly, we clearly denote where the initial and final points are. So I've kind of laid it out for you. Initially, the two cars have these velocities, and then finally, after the collision, we have one velocity but not the other. So it's the instant before and after the collisions is what we're talking about, before and after. Next, I draw my momentum buckets. So each one of these buckets is one of these objects, and I basically ask myself, is it moving or not? Does it have a velocity? Because if it has no velocity, then it has no momentum. It may have a mass, but maybe not momentum. So car 1 is moving, so it's going to have some momentum here, something in the momentum bucket. Car 2 is moving, has some momentum. After the collision, car 1 is still moving, although a little bit slower, and so is car number 2. So all buckets have some momentum in there. So qualitatively, we can get a feel for everything has some momentum, maybe some higher, some lower. We're going to quantify that in a second. So in this case, we have every single term here. So my momentum equation is this basic equation right here. The only time it wouldn't be this if there were something not moving and it were 0 and were to cancel out. But in this case, everything is there. So this is my momentum equation right there. The next step, I solve. So I'm going to take my equation and I'm going to use the numbers that I'm given. And this is basically math now, accounting for all the variables. So M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. And this is what I'm solving for right here. There's an M right there. So plugging the numbers here, I get what? Let's see, 2 kilograms times 5 meters per second plus 1 kilogram times 2 meters per second. These are the given numbers from the top here. Here we have 2 kilograms, and it slows down to 3 meters per second. Oh, excuse me, 2 meters per second, I believe. And this is still 1 kilogram. That's a plus sign there. This is not a equal sign. This is M2, which we know is 1 kilogram. So I should probably put a 1 there. One times my final velocity 2. So on the left-hand side of the equation, I have 10 plus 2, which is 12, equals 4 plus v final. And so my final velocity is 12 minus 4, which is 8 meters per second, which seems pretty fast, but recall that the mass of the second car is 1 kilogram only, whereas the first one is 2 kilograms. So the mass during the collision has an effect on it. So we can say that the final velocity is 8 meters per second. It's a positive value, meaning it continues to go to the right as opposed to go backwards, which sometimes happens in collisions. And so this is V2 final. There's a final answer of 8 meters per second. To check your work, you can plug this back in here and say 2 times 2 is 4, 1 times 8 is 8, and so both sides of the equation should be equal. And those are the steps to use to solve an elastic collision type problem. Use the law of conservation of momentum.